Hey guys, quick little update on distributive property. You want to make sure that you talk about or show that both forms are equivalent. Here we have what's known as an expanded form of the property, and here is the factored form. We know it's factored form because there is a factor out front. This 2 right here is a factor of this expanded version of the form. So let's take a look to see these two are actually equivalent to one another. Okay, so if we use our area model and take our rectangle here and find the values of that group, you have 8x plus 6y. And in this grouping here, they're both even numbers and they both don't share a variable. One, we cannot combine like terms because they are not like terms. They don't have the same variable or the same exponent. But the numbers, the coefficients in front, there is something related there. They are both even numbers, so we can factor something out. Okay, so within this, what do they share in common? Well, we can factor out a 2 because they're both even, so what's left? So 8x divided by 2, well, there's an x left because we did not factor that out. Okay, and what is the value that is left? 2 times 4 is 8. So really we have 4x right there. Okay, that value is 4x. So what else do we have? 2 can factor out of a 6, and there are 3 left over, and again, the y stays. So we have this here, the 2 is a common factor, 4x and 3y. Look over here, 2 and 4x plus 3y. So again, this is the expanded form that was given to us. This is the factored form. In the factored form, we can multiply back in. Show one of 2 ways. We can factor this 2 to both terms inside of the parentheses, terms separated by addition. So 2 times 4x is 8x. And then the 3y times the 2 plus 6y. Same thing. We could also show it like this. If we set up our area model again, okay, and we had that common factor over here, right? We then put the factored terms 4x and 3y, and we'd be able to multiply this in to get back to the expanded form. This side length is 2. This side length is also 2. So 2 times 4x to find the area of this model would be 8x. And the area of this model would be 6y. 2 times 3y. We get back to that value. So it is the same thing as we go forward. Now you could also find any other possibility of this. The perimeter, for example. The perimeter here would be, let's get rid of the area. If this side length is 2, and it's a rectangle, this congruent side over here is also 2. Okay? And the side lengths here are also the same. This would be 4x as well, and this would be 3y. So if we're finding perimeter, okay, so perimeter equals the sum of all the sides, we add them all up. I'll start here and I'll go clockwise. So we have 2 plus 4x plus 3y plus 2 plus 3y plus 4x. And if we take a look here, okay, I'm going to erase this so we can see a little better. Are there any like terms that we can combine here? Well, yes, of course there are. Okay, the perimeter equals 2. This is a number, and this is a number. Don't forget the sign in front, the plus 2. So 2 plus 2 together would be 4. Plus, well, how many values of x are there? There's a plus 4x, and there's a plus 4x here. So 4x and 4x together makes 8x. What about the last part here? So plus 3y and plus 3y plus 6y. So the perimeter would be this value. We don't know what the value of x and y are yet, but if we were told what they were, we could find the perimeter of this. We could find the exact perimeter. We could find the exact area. And if there's a third dimension, we could find the exact volume, or how big this actually is. So keep that in mind. Make sure that you are continuing to work through this, and keep checking in just for updated videos and everything. Okay?